Bismillahirrahmanirrahim. Assalamu alaikum to my viewers and students. Welcome to my channel. In this video, I'm going to show that how we can perform simple moderation analysis in PLS SmartPLS version 4. And this is my base model on which I am working, and I have made a series of videos using SmartPLS 4 version. In this model, you can see here that there is a single moderator I have included between the independent variable and the first mediator, you can say. The further it was a sequential mediation, and this is the dependent variable. So we have to analyze the effect of moderator between the IV and mediator one. Let's move to the towards the SmartPLS version 4, and I have to copy the base model, take its duplicate, and should name as simple moderation analysis, and now click on the simple moderation analysis. In earlier videos, I have told you that first of all I uh, validated this model by performing different model fit measures like confirmatory effect analysis, average variance extracted, and factor loadings and other things were all checked in my first video in which I have formulated this model. And after formulation or validating this model, I further work on it by doing mediation, moderation, or regression analysis, and extracted all the structure equation models for different analysis from the on this base model. So again, in this case, I have to delete the other variables that are not required in moderation analysis. Here we just take the three variables. The three variables are the my mediator one is now becomes a dependent variable. This is the moderator, and whose effect, moderation effect, we have to analyze between the independent variable and the dependent variable. So for ease, I have to show that actually what moderation how moderation works. Simply, the moderation concept was is that without moderator, we notice that we examine the direct effect IVs on mediator one, that becomes beta one. Definitely, by dropping the moderator variable, we have already tested the direct effect of IV on mediator one. But how moderation basically is performed, we include some moderated second variable, and we can in simple way, now the software will work automatically and calculate the moderation effect here directly, but to understand that actually what is the moderation and how it works, IV on DV effect is analyzed, then we by theory suggests that there is a moderator whose on different values the effect on effect of IV on mediator 1 changes on the different values of the moderator. So for example, moderator, if I so far not include the interaction term, we can analyze the direct effect of moderator on the or dependent variable, and you can here check here. Let me execute this analysis. For we go to the calculate option, and I have not included moderating effects so far, and simply run a consistent PLS SEM bootstrapping, as my all factors are latent variables, so it is a preferably to use to the consistent PLS SEM algorithm, and it will be executed. The report will be shown here. Let me zoom in, and Now you can see here the auto loadings are shown on the outer side of the items, and for inner the path coefficients are shown, and we didn't check the p-value. We are not concerned here for the significance of the both effects on the dependent variable. And the r square is shown here. The r square is a 0.417, and just let me write it here, that the r square for this model without including the interaction term, the r square is the 0.417. Now moderation effect is actually the moderation effect is actually is the we analyze the product of IV and moderator effect on the dependent variable. Their software automatically calculates the interaction term, and the interaction term is actually calculated by multiplying the given independent variable and the moderator variable, and this interaction terms effect on the dependent variable is analyzed, and it will be named as, let's suppose, beta 3. Now after incorporating interaction term, we are concerned with the this interaction term, not with the beta 1 and beta 2, although in analysis or interpretation we write the effect of the IV on mediator, moderator on, sorry, dependent variable, and for finally on for moderation significance we relies on the interaction terms coefficient. If this coefficient is significant, then we can say that there is a moderating effect, presence of the moderating effect between the given variables. Another thing you will notice that by incorporating the interaction term, if the r square will be changed, and if the r square changes significantly different from the previous one without incorporating moderating effect, then this will also show that the moderator has significant influence or significantly moderate the relationship of IV and the dependent variable. Now how we can check this one? Here r square for the model without incorporating the interaction term is a 0.417, and we move backward, we move to back, and now include the moderating effect. In SmartPLS for version 4, we can include the moderating effect by simply clicking on the moderating effect, then draw a line, basically effect from moderator to the where you want to analyze the moderation effect. For example, in this case I have to check out the moderation effect between IV to mediator 1. So I will click from moderator to this arrow and leave, or click on it. It will create a dotted line. This dotted line is basically the interaction term. This dotted line is actually the interaction term, and software automatically calculate the interaction term by multiplying the IV's values with the moderator values, and it's overall, if in back to the back of the software, it generates the standardized value and find out the effect on the IV on DV. So this is interaction term, and let we check the effect of interaction term on the dependent variable. Again, for to check out the r square value, I simply run a again consistent PLS SEM algorithm, and we will get simple path coefficients with their r square values. And if you can see here, the r square for this model becomes 0.431, and this r square is increased. Now you can notice that the first one was 0.17 and the second one is the 0.431 by incorporating the moderating effect. And the change in r square is actually calculated by subtracting 4.17 from 0.417 from 0.431, and it will be I think 0.14. This effect change in R square it's about 1.4% change in the R square value, and it is it if this is a significant change, then we can consider that there will be a significant change on the moderator on the independent to dependent variable, or for your as your theory suggests, or your according to your model. The R square change from 0.437. Okay, I will show you the its p-value, and let's move with the consistent PLS SEM bootstrapping and analyze its to calculate its p-value. You can change a different confidence interval method, or its bootstrapping sample should be on 5000, and PLS setup should be on path analysis and standardize, and just click on the start calculation option. It will take a little bit time to execute the analysis and will provide us the results with the p-value probability values. The p-values or the probability values will tell us about the significance of the results. The results are generated now. In inner model, you can see here the values are 0 0 0 0 are the basically p-values which are mentioned in, like in outer model are also representing p-value. Inner model is also on p-value. We can change it here from outer weight loadings, and with respect to p-values or just simply click on the t-values. T-values must be greater than 2. For inner model, we preferably select the path coefficient and p-values, and R square is not shown in the construct when we use the bootstrapping method. It is only shown when we have simple algorithm, PLS SEM algorithm, consistent algorithm, or algorithm, then R square and other like AVA, Cronbach alpha, and other things will be shown within the construct. Now simply you can see here that the IV has a significant effect on the this variable like mediator 1a, or this is dependent variable, and similarly moderator's direct effect shown in a bold arrow is also significant. And for moderating indirect effect, sorry, not indirect effect, a moderating effect, basically the interaction term, has also the significant negative effect between the IV and DV. Now here the effect is the negative, and negative shows mean by with the low value of moderator, because we mostly interpret the effect of moderator on its low and high value, and in most of cases I will explain it into moderation graph. At negative mean indicate that with the low value of moderator, IV's effect on DV will have positive or maybe more effect on the mediator, but with the high value of moderator, this effect become less. In this way we can explain the moderation effect between the given two variables. For example, we can go to the path coefficient table, and in path coefficient table we here can see that IV's effect on mediator is a 0.358, and it is significant. Moderator effect is also significant, but interaction term moderator into IV effect on mediator is a negative minus 0.14, and it is significant. If the interaction term is significant, then your hypothesis for moderation will be accepted. If your hypothesis is drawn that the moderator has negative significant moderation effect between the IV and dependent variable, then your hypothesis will be selected here as its p-value is less than 0.5. If its p-value is greater than 0.05, it will be marked as a red, and red mean it is a insignificant, and if it is insignificant, then there is a no moderation effect between the given variables. So in this way we can analyze the simple moderation effect of the given two variables and the moderator. For moderation graph you have to run, the moderation graph is not shown in the simple consistent PLS algorithm. It is just incorporated in the PLS SCM algorithm option. In the I think in a prior version when we used the SmartPLS 3, the graph is also generated with the consistent PLS SCM algorithm, but in this SmartPLS version 4, the moderation graph is only produced when we run PLS SEM algorithm. So I click on the PLS SEM algorithm, and it will has same setting, and it is on the path analysis. Just click on the path analysis, and definitely there will be a little bit change in the results when we run this PLS SCM algorithm, and when we run the PLS SCM consistent PLS algorithm. If you notice that this value 0.117 was actually I think 0.140, but its value has no changed. But there is a certain difference in running the two method PLS SEM algorithm and consistent PLS algorithm. Here you can see in the residual section the path coefficients are shown here. I have not run with the bootstrapping, so therefore only the coefficients are shown here, and the p-values are not shown here. And for it was PLS algorithm was run to get this simple slope analysis or the graph of the moderation effects, so it is shown here. Now for the negative effect, the important thing here is that basically this graph is the shows the conditional effects of moderator with the low value at the mean at the one standard deviation above. The model automatically calculates the standardized value of each variable, and you can see here there is a on x-axis it is an independent variable, and on y-axis the dependent variable. This graph is drawn between independent and dependent variable with considering the conditional effect of the moderator, the basically the interaction term. And here it is mentioned that the this red line is basically shows the -1 standard deviation. Blue line is the at the mean value, and red line is the below to the one standard deviation, or you can say that the subtracting one standard deviation from the mean value, and the above green line is the mean value plus one standard deviation of the above the one mean value. So if you notice that the red line is showing increasing trend, it's moving upward. This shows that when there is a low value of the moderator, there is a positive association between the IV and or given dv variable, and there is a when there is a no moderator or a moderator had low value, the increase in independent variable will also take positive change in the dependent variable. But the interaction was a negative, has a negative effect, I think 0.117 in this case for this negative effect. at the uh, one standard deviation above the mean value, that is shown in the green value, and the green line is showing the trend moving towards bottom. It's not, its trend is not increasing, but its trend is decreasing. Actually the slope of the line is not increasing, it is decreasing. At some later stage they both red or green may cross each other, and this decreasing trend shows that with the increase in the value at a lower value of the moderator, there was a high effect on mediator, but at the high value of the moderator, now the effect becomes low. IV's effect on a dependent variable will low, and it will show a decreasing trend. In you can say in most preferably thing, our graph can be shown here. If we have a red line, for example, this is a this line was with the one standard deviation below, and for negative moderating and for negative moderating effect, the line with the plus one standard deviation should be like this, the one standard deviation, that at low value of the moderator, the effect is IV's effect on dV is positive or increasing, but with the high value of moderator, this effect become low or decreases. You can better understand by your hypothesis you formulated according to your study, in which exact relationship is explained according to the moderator. Similarly, if we have a positive moderation effect, for positive moderation effect might be in at the start at a low value we have moderation curve line with a minus one standard deviation is just like flatter or a low, showing low increasing trend, but for with the high moderating effect it will be at high value of one moderator, it will have a positive effect and it will show increasing trend. With the increase in the value of IV, dependent variable will also increase. So this was all about the simple moderation analysis. In next video I will show you how the moderated mediation analysis works. So thank you very much.